Good morning to all. Myself Dr. K. Manoharan, Associate Professor, Department of Biomedical Engineering. So today class we are going to see about 8255 interface, that is programmable peripheral interface. That is we can call it as PPI. So this 825 is popular for programmable peripheral interface chip developed by Intel. It is widely used for a microprocessor-based system to interface some input or outputs. So inputs like a sensors, switches, and other things. Similarly, outputs like in relays or any activators, display devices. So these devices will be connected to the microprocessor through this 8255 interface. So 8255 it's an 8-bit general purpose IO, that is we can say it is a GPIO, general purpose input output chip. So it consists of 8-bit ports. So it will be called as port A, port B and port C. So each port, that is a port A, port B, port C, all have an 8 bits. That means so 3 into 8 lines of IOs can be connected. All the pins in the port A can be used as an input or output. Similarly port B and port C also. Look at the block diagram for this 8255 interface. Look at this. First one, this is a data bus buffer. So it connects an internal bus with this external microprocessor. It may be 85 or 86, any microprocessors. Look at this. This is an read-write control logics. So read signal, write signal, A1, A0. This is an address line A0 and A1, and reset signal that will be connected here, and then chip select. So read bar, write bar, that will be used for a read operation or write operation. So whether we are going to perform a read operation or write operation, that decide this read bar, write bar. Whenever we are connecting an input signal, that is an IO port. So input port we are connecting, we need to read the data from the input port. Whenever we are connecting some output ports like a display devices, we need to make it as a write. So whether it is an input operation or write that is input operation or output operation, that decides this read or write operations. Similarly, this A1, A0, this will be used for this, whether we are going to use port A or port B or port C, or whether the data is for control weight register. So that decides this A0 and A1. So control weight register is used for whenever you are writing some control weights, whether which mode of operation, again which port, and which the data we are going to transfer. So these will be given for the control weights. So we have a different mode of operation, and then we have this whether input or output, that will be decided by the control weight. So we need to finalize a control weight, and that control weight should be loaded to the control weight register. So then only that particular configuration will be happens. Chip select remaining address line will be connected to the chip select to decide a one address. So port A, port B, port C, each one have the separate addresses. Also control weight register have an separate addresses. Reset signal also connected here. Look at this. We are going to divide into two groups. So this is the group A control, and this is called group B controls. Look at this. So group A comes under this. So inside this group A, we have two things. One is a port A, and another is a port C upper. Upper means actually port C is an 8-bit. Higher 4 bits will be called as an upper port C upper, and the lower 4 bits will be called as a port C lower. Look at this. So this is a port C upper 4 bits. So this will be combined with this group A signal. Similarly, look at this group B. So group B comes with this what is that? Port B also with this port C lower. So actual port C is divided into two things, lower 4 bit and higher 4 bits. That lower 4 bits will be clubbed with this group B, and then higher 4 bits will be grouped with this group A. So and port A will be always combined with the group A, and then port B always combined with the group B. Look at this. So here we have group A, it have an 8 lines, PA0 to PA7. This is only 4 bits because it's in port C upper. So we have PC4 to PC7, higher 4 bits. Actually PC0 to P7, there is lower bit PC0 to PC3 will be taken as a lower, and PC4 to PC7 higher 4 bits will be grouped into upper 4 bit. So these 4 bits will be comes under the group A. Look at this group B. So group B, we have this port B, PB0 to PB7, all 8 lines, and then port C lower, that is a PC0 to PC3. So these comes under the group B signals. So why we are doing this means, so whenever you go for a mode 1 operation or mode 2 operation, we need some handshaking signals. So for this handshaking signals, we use this port Cs. So actual database will be work as an there is a port A and port B. So these port C signals will be used as a group. So that's why they are splitting like this. Look at this control weight register. So first bit D7, this is a BSR mode or IO mode. BSR mode means bit set reset mode. So this will be used only for port C operations. IO mode. So this must be 1 to choose the IO mode. Actually, this is an IO control bit. So for a choose an IO operation, the bit must be a 1. Look at this. So this bit will be a group A signals and this is a group B signals. So group B, so look at this. This D5 and D6 that will be used for a mode selection. So this D5 and D6, if it is a 0, it selects this mode 0, and 0, it selects the mode 1, and 1 don't get, it selects the mode 2 operation. Look at this D4, so this will be used for an port A. 1 means input port, 0 means output port. Look at this D3, so D3 is a port 3 upper, so this puts 1 means input and 0 means output. Look at this group B side. So first one D NAT, that will be for a port C lower, 1 means input and 0 means output. And D1, this is a group port B, so 1 means input and 0 means output. Look at this mode selection. So here only one bit will be used. So that means D2 will be used for a group B. So 0 means mode 0, 1 means mode 1. So mode 2 is not possible. So mode 2 only supports for the group A signals. So mode 2 is a bidirectional data transfer that can be controlled only using this group A. That is a port A only alone used for this. Thank you.